y'all. Today we're going to be looking at one-to-one functions and inverses. So one-to-one function is if no y in the range is the image of more than one x in the domain. And you can test this by doing the horizontal line test. So you can take your pencil, anything, and put it horizontal. And if that touches the graph more than once, then it's not a one-to-one function. And then verifying your inverse, we did this on the last question of 5.1, and it's doing the composite of f of g of x equals g of f of x, which equals x. So let's go and verify an inverse. So the first one we have is g of x equals x cubed, and then the inverse is the cube root of x. So we're going to go and identify if this is true. So let's do g of the g inverse of x. So we're going to take the inverse and plug it into g of x. So we have the cube root of x cubed. And then the cube root and the cube cancel each other out to make x. Now let's do g inverse of g of x. So we'll plug in x cubed into that cube roots. And so, again, the cube gets canceled with the cube root to have x. So, therefore, these are inverses. Alright, so now we're going to see if 2x plus 3 and 1/2 times x minus 3 are inverses. So let's do f of f inverse of x first. So let's plug in 2 times 1/2 x minus 3 and then plus 3, which equals x minus 3 plus 3, which equals x. Okay, so now let's try f inverse of f of x. So we have 1/2 2x plus 3 minus 3. That's 1/2 times 2x, which equals x. So they both equal to x. So therefore, they are inverses. All right, let's try the next one. And then we're also going to have to state the excluded values here. So we can look at the excluded values now, and that's just on both f and the inverse of f. What can the denominator not be to make it 0? So for f, we could say x minus 1 can't equal 0, x can't equal 1. And then for f inverse, we say x can't equal 0, so x can't equal 0. So those are excluded values. All right, so let's try f inverse of x first. And we should get 1 over x plus 1 and then minus 1, which is just the plus 1 minus 1 cancels, so we got 1 over x, which just equals x. Now we'll do f inverse of f of x. And so we have 1 over x minus 1, and then plus 1 on the outside. If we simplify this, and we should get, if we take 1 divided by 1 over x minus 1. We can multiply by the reciprocal, so 1 times x minus 1, which just equals x minus 1, plus 1, which just equals x. So again, therefore, these are inverses, because we ended up with x at the end. Okay, so now we're going to take a look at this graph and we're going to draw the inverse function of it. And what you do is you just flip the x and y values. So let's start with the furthest left point. That point would now be -1, -2. This point up here, the middle one, would be 0, -1. And the very right point would now be 1, 2. And now we're just going to graph it again over to the side with those new points. So 1, 2, 3. 1, 2, 3. We have the point 1, 2. We have the point 0, -1. And then the point -1, -2. Let me just go put those in pink for us. Go over them. And then draw our line between those points. So that would be then y equals f inverse of x. So now when you're given an equation and you're trying to find the inverse, you just switch the x and y values. So right now, when we have f of x equals 2x plus 3, that's really y equals 2x plus 3. So step 1 is you're going to switch the x and y values. So now we're going to have x equals 2y plus 3. Now we're going to, so I'm going to say switch x and y. Then step 2, we're going to solve for y. Solve for y. Then we can say, we can start by subtracting that 3 to the other side and get x minus 3 equals 2y. Then divide by 2 and get 1/2 x minus 3/2 equals y. And then they want us to graph both of these. So we can go ahead and draw our graph. So the first one has a y-intercept of 3. I'll do f of x in pink. So a y-intercept of 3 and then a slope of 2. So we can go up 2 over 1 or down 2 over 1. Just get this as close as possible. And then just draw our line through there about like this. So y equals f of x. Now let's do the inverse in blue. So we start at -1/2, and then we go up 1 over 2, and then up 1 over 2. And then we can just draw our line through there, just about like this. And this is y equals f inverse of x. And then you can tell that these lines are symmetrical through this oblique asymptote of y equals x. Okay. For this last problem, we're given the function f of x equals 2x plus 1 over x minus 1. And we know that x cannot equal 1 because that would give us a 0 in the denominator, which would make this undefined. And we know this is a 1-to-1 function. So we are trying to find the inverse of this function and then double check our result is right. So step 1 is replace f of x with y. So we have y equals 2x plus 1 over x minus 1. Step 2, we are going to swap x and y. So we now have x equals 2y plus 1 over y minus 1. Step 3, solve for y. I'm going to start by multiplying both sides by y minus 1 to get rid of the fraction. So I'm going to end up with xy minus x equals 2y plus 1. I'm going to put the y's on the same side. So xy minus 2y minus x equals 1. I'm going to put x on the other side and get xy minus 2y equals x plus 1. On the left side, I'm going to factor out a y because they both have it in common and have x minus 2 equals x plus 1. Then to solve for y, I'm going to divide by that x minus 2. So I'm left with y equals x plus 1 over x minus 2. So here we want to state the excluded value, and that is x cannot equal 2 because 2 minus 2 would be 0 in the denominator, making it undefined. So now we're going to check our work. So check. Let's do f of f inverse of x first. So we have 2 times x plus 1 over x minus 2 plus 1 over x plus 1, x minus 2 minus 1. If we expand this out, we would get 2x plus 2 plus x minus 2 over x plus 1 minus x plus 2. And if we simplify this, we should get 3x over 3, which just simplifies to x. Now let's try f inverse of f of x. And so we have 2x minus 1 over x minus 1 plus 1 over 2x minus 1 or plus 1 over x minus 1, that's plus, and then minus 2. If we distribute, get common denominators, and start solving, we get 2x plus 1 plus x minus 1 over 2x plus 1 minus 2x plus 2, which simplifies to 3x over 3, which simplifies to x. The composite functions of the function in the inverse both simplified to x. So yes, these are inverses, and we stated the inverse above, and that is all. If you have any questions, please feel free to ask.